So as of this point, we now know how to find zeros from a graph. We find the x-intercepts. We know how to find zeros from intercept form, both in the simple case where the coefficients of x are 1, and then when it gets a little bit more complicated and we have non-1 coefficients. The next thing we need to discuss at the top of the next page, finding zeros from standard form. As I mentioned on the previous page, intercept form is definitely the easiest to deal with when finding zeros, especially the coefficient of 1 case, although as you also saw, finding zeros from the graph of a function is extremely easy too. Standard form presents a little bit of a difficulty. We're going to actually have to do quite a bit of work to find the zeros from standard form. There are some things that we're going to discuss later, some things we can memorize that might help us find the zeros from standard form without doing a ton of work. But what we have to talk about right now is factoring. We have to talk about how we get standard form converted into intercept form. So first of all, let me back up here. Remember, standard form was that f of x or y equals ax² plus bx plus c. I did mention before that that tends to be the form that students are most familiar with when it comes to quadratics. What we can do if we're given standard form and we need the zeros, let's say we don't have a graph, let's say we're not given intercept form, well, what we can do is we can convert standard form to intercept form by factoring. Now, many juniors, many seniors, even most sophomores have methods for converting standard form to intercept or factored form. If you have a method that works for you, no matter how complicated the quadratic gets, then just go ahead and use that method. I would, however, recommend watching the method that we go through here, which most students will know as a factoring by grouping method. That's what we are about to discuss. This method tends to be reasonably straightforward, reasonably efficient. I will say that the vast majority of the quadratics that you might have to factor on this test are going to be fairly simple. So you might see stuff like x² minus, let's just do minus x minus 20. And let's say this were a quadratic function, and let's say you had to find the zeros. Most students, by the time they're juniors and seniors, can look at this and by a little bit of trial and error figure out that, okay, you need these two last numbers when you FOIL these two factors out. We're going to talk about foiling later, although again, most people should be familiar with that term FOIL. If I want to get a negative 20, I need something like a 20 and a 1, or a 10 and a 2, or a 5 and a 4, but I also need those two values here when everything is all FOILed out to produce this negative 1 in front of the x. And of course, the factors of 20 that will produce a 1 or a negative 1 will be 5 and 4. We need to produce a negative 20, so one of these has to be negative, one has to be positive. In order to get that negative 1, we're clearly looking at the case where we have negative 5 and positive 4. And indeed, x minus 5, x plus 4 is what this standard form quadratic factors into. And if I FOIL this back through, I get x² plus 4x, x² plus 4x, minus 5x, minus 20, and of course, plus 4x minus 5x is negative 1x. That's 4 minus 5 is negative 1. This is just, the standard trial and error or guess and check or visual examination method. And this method is going to be fine in the vast majority of cases where you might want to factor a standard form quadratic. However, again, it might be good to know a more robust, more systematic way of factoring quadratics, just in case you get a quadratic that is a little bit more complicated, a little bit messier. So, how are we going to do this? How are we going to factor a standard form quadratic and convert it into factored or intercept form? Well, first of all, we always want to make sure our equation is in pure standard form, where we have all of our quadratic, our linear, our constant, quadratic, linear, constant terms on one side and a 0 on the other. In other words, we have the form ax² plus bx plus c equals 0. So if I want to do that with this example here, I am simply going to take that 40 from both sides, and I am going to get x² minus 4x minus 40 equals 0, and now I have my equation in standard form, pure standard form. Next step, if there are any factors common to all of the terms, I've got 3 terms here, this is known as a trinomial, I do have something common to all these terms. I have a 4, and I believe that's it. I don't have x's common to all 3. I don't have anything bigger than 4 common to all 3. So I'm going to factor out a 4, and what I'm going to be left with inside is 2x squared minus x minus 10. I do, after factoring like to quickly run through with a little bit of distribution to make sure I didn't mess anything up. 4 times 2x squared is 8x squared. 4 times negative x is negative 4x. 4 times negative 10 is negative 40. I got everything perfectly fine. I'm going to then list the values of a, b, and c in the simplified or factored quadratic that I've made here. So a is going to be 2. That is the coefficient in front of the quadratic term. B is the coefficient in front of the linear term, and then that of course is a negative 1 here. And the c is the constant term here, that's negative 10. What I'm going to do now is I'm going to draw an x. Drawing the x isn't absolutely necessary, but it's fun to draw a big X, so I'm going to do that. In the top quadrant up here, I'm going to write the product of A and C. The product of 2 and negative 10 is negative 20. And in the bottom quadrant down here, I'm going to write the value of B, which is negative 1. My next step is to list all the pairs of factors of AC and find the pair that when added give me B. That is sort of what we were doing in the little example that I did up here, you will recall. So I'm going to list my factors of 20. I'm not going to worry about the negative right now. 1 and 20, 2 and 10, 3 no, 4 and 5, 5 and 4. As soon as I reach a number in that first column that I've already listed in the second column, I know I'm done. So here are my factors of 20. And of course, just like in the example I gave you, the 4 and the 5 is the pair that is going to multiply to 20 and somehow give me that negative 1. I do have to figure out what the signs will need to be. In this case, same as the example above. I have a negative 5 and a positive 4. So I have written, I'm on step 5 here, I have written those factors in the left and right quadrants, but what I want to now do is I want to put an x after each of those. So negative 5x plus 4x. Now what I am going to do is I'm going to rewrite the quadratic that resulted after step 2. That was this quadratic in here. I'm going to rewrite that, but I'm going to rewrite the middle term, the bx term, in terms of these two. I'm going to sort of break that negative 1 into a negative 5x plus a 4x. Negative 1x is going to become negative 5x plus 4x. So 2x squared minus 5x plus 4x minus the 10. If I want to put the 4 out here, it's actually not a bad idea to do that just in case, just so we don't drop it. I do remind you in a later step to make sure you throw back in that number that you had factored out in step 2. So now what I'm going to do with this stuff in here is I'm going to, this is step 7, I'm going to factor the first 2 terms and the last 2 terms separately. So I'm going to look for something that is common to 2x squared and 5x, and of course that's just an x. So here's what I have. I'm going to pull that x out. So x times 2x minus 5, again, just to distribute x to 2x, that gives me the 2x squared, x to negative 5, that gives me the negative 5x. And from the 4x minus 10, what can I pull out there? I can pull out a 2. So I'm going to pull out a 2, and inside I'm going to have 2x minus 5. I'm going to write the rest of my equation there. So again, I pulled an x out of the first 2 terms, out of these 2 terms. I pulled a 2 out of these 2 terms, and I'm left with this. Now, if you have done everything correctly up until this point, what you will always see is you will always see a common factor up here. So I have x times 2x minus 5 and 2 times 2x minus 5. I can pull that 2x minus 5 out of those 2 terms. So if I pull a 2x minus 5 out, what I am left with is x plus 2, right? Because if I distribute this 2x minus 5 to each of these terms, I will just end up with what I had up here. That 2x minus 5 is just, you could just think of it as like an n. I'm just pulling that n out. This is xn plus 2n. If I pull the n out, I would get n times x plus 2. Well, there's the n. There's the x plus 2. So now what I have is I have this, and that's it. I'm done. That is my final factored or intercept form equation. Now what I might want to do, as I've said several times, is I might want to distribute everything through. So I'm going to FOIL this. So that's 2x times x, that's 2x squared. 2x times 2, that's 4x. Negative 5 times x, that's negative 5x. Negative 5 times 2, that's negative 10. Still have the 4 out there. Let me combine these two terms. So that's 2x squared minus x minus 10. Everything's looking good so far. Put that 4 back in. I get 8x squared minus 4x minus 40. Is that what I had at the very beginning? Yes, it is. Pretty much after the first step, that's what I had. I could even rewrite this as that plus 40, and then of course I have exactly what I started with. So again, what you want to do is factor out anything that's common to all three terms, look at what trinomial results, write your a, b, and your c, draw your x, get your ac up at the top, get your b down at the bottom, find the two factors of the ac product that will add or subtract to give you b, rewrite the middle term as a sum or difference of the two items in the left and right quadrants of the x, and then factor by grouping. You take what is common to the first two terms, take what is common to the second two terms, pull those things out, and you will end up with a common factor. Factor one more time, and you should be done. Yes, it's a little bit of a tedious process. Yes, there's obviously a lot of steps to it, but number one, some of you are already familiar with this process, and number two, the good thing about this process is if you follow all the steps perfectly and to a T, you will be able to factor most of the quadratics that you encounter on this test in this way. At the top of the next page, we are going to try an example here using the process on the previous page. I would pause the video and try to do example 8 on your own. Obviously, you can look back to the previous page. I would definitely recommend following the process step by step. As I said, you got to follow it to a T, and as long as you do, you should be fine. So try number 8 on your own. When you are done, or obviously if you get stuck, start the video again and join us. So in example 8, what do we have to do? We have to find the solutions to this. This is actually a cubic. Find the solutions, the values of x that satisfy this equation. So from the previous page, again, you can flip back there if you need to. We want to rearrange the equation so that everything is on one side and a 0 is on the other. So I'm just going to start by subtracting the 9x from both sides. Let me zoom in here a tiny bit more. We get 12x cubed plus 12x squared minus 9x equals 0. So everything is rearranged so that we have a 0 on one side and all of our other terms on the other. The next step, step 2 from the previous page, says to factor out any numbers or variables common to all terms. And of course here we have an x common to all of our terms. We also have a 3 common to all of our terms. We can pull a 3 out of those two 12s and that 9. So we're going to pull a 3x out, and then figuring out what we need inside parentheses, we can either do 12x cubed divided by 3x, or we can figure out what we need to multiply 3x by to get 12x cubed, and of course that would be a 4x squared. So 3x times 4x squared would be 12x cubed, so that's good. This is just going to be a 4x. 3x times 4x is 12x squared, very good, and then minus, it looks like minus 3 there. 3x times negative 3 will be negative 9x, so that all looks good. What we do next is for the quadratic, we're going to list our values of a, which is 4, b, which is 4, and c, which is negative 3. So a, b, c, we have our values listed. The next thing that we do, of course, is we draw our large x. And remember that in the top quadrant, this is step 4, by the way, in the top quadrant we write the product AC. In our case, AC, a times c is 4 times negative 3, which is negative 12. And down here in the bottom quadrant we write our b value. Now what we do is we list all of the factors of negative 12. So I am just going to list the positive factors. So I'm going to do 1, 12, 2, 6, 3, 4, and we have to find out which pair is the one that adds or subtracts to the 4 down here. And of course that's going to be the 2. And the 6, we need to make a negative 12 and a positive 4. So it looks like we need a positive 6 and a negative 2. And remember, we're going to throw an x after each of those. Two x times 3 is positive 6x. Two x plus 3, and 2x plus 3, of course, is that common factor that we said would be apparent at the end of step 7. So we do see that common factor, and now of course I pull that common factor out. I am going to come up here. Let me give myself a little bit more room. That's a little bit too much room. There we go. So we've got 3x, and then what I'm doing is I'm pulling out that 2x plus 3 from each of these two terms, and I am left with 2x minus 1. I am left with this item and this item on the outside. And of course, if I distribute that 2x plus 3 to the 2x and that 2x plus 3 to the negative 1, I would end up with what I had over here, which resulted from this step, and so on and so forth. So everything looks good, and it appears I have just factored completely the original cubic. And now what I do to find these, so these are the factors, these are the three factors, 3x, 2x plus 3, and 2x minus 1. Now remember, I should actually distribute this and make sure that everything works out well. 2x times 2x is 4x squared. So 3x is on the outside. So 2x times negative 1 is minus 2x. 3 times 2x is plus 6x. 3 times negative 1 is negative 3. If I then distribute that 3x, I get 12x cubed. I get negative, actually let me just combine these. So this is just going to be positive 4x. So that's 3x times 4x, which is positive 12x squared, and then 3x times negative 3, which is negative 9x. And of course on the right I'd still have that 0, and that does look exactly like what I started with. That was the original equation here, 12x cubed plus 12x squared minus 9x. So the factors are correct. These three factors, 1, 2, 3, those are correct. And remember, to find the solutions, I can use the zero product property here. I can set 3x equal to 0. I can set 2x plus 3 equal to 0. I can set 2x minus 1 equal to 0. Obviously over here, x is just going to equal 0. Minus 3 minus 3, I get 2x equals negative 3. Running out of room here. So there, x equals negative 3 halves. So I've got a 0, I've got a negative 3 halves, and then of course over here plus 1 plus 1, 2x equals 1, divide by 2, and I get x equals 1 half. So 0, negative 3 halves, and 1 half are my three solutions here. 0, negative 1 half, and positive 1/2, and negative 3/2. I did that a little bit out of order, but that's okay. And of course, if this were a grid-in, somehow the question would restrict you either to the 0 and the positive solution. The negative solution could not be possible on a grid-in. Now, of course, that process did take several minutes. The more you practice this process, the better you get at it, the more efficient you get at it, the less time it will take. I would say that somebody who's proficient at this process could probably factor this cubic and find the solutions in a matter of a minute or two. It should not take very long to do this process once you're familiar with it. So practice away.